Okay, video 2 for lesson 1. So this should finish very quickly. Only 2 slides, 2 problems to look at. Okay, so it says, over what interval is f of x equals 4x squared increasing? Over what interval, or over what interval is it decreasing? Okay, so let's take a look at this problem here. Now, for this, I want to have a picture in mind. Okay, so I always like to start with the parent function. So 0, 0, 1, 1, 2, 4. Negative 1, 1, negative 2, 4. So this is my parent function. I'm going to dot it. Okay. So this f of x equals 4x squared, right? Your a value is 4, which means you're going to open up and be narrower. Narrow. So we can use Desmos to graph this, and I'm going to just save you the trouble. So 0, 0 will still be on the graph. We're not moving it. But instead of the point 1, 1, it's going to be at the point 1, 4. So 1, 4, 1, and then negative 1, 4. And it's going to look like this. So this is what that graph looks like. Again, it's more narrow. And again, you can just type it in Desmos. I'm actually going to show you that before we leave, how to get that table of values again. So the question is, when is this blue graph increasing and when is it decreasing? Well, because it opens up, right? Again, your vertex is still 0, 0. If we go from left to right, so again, as we go left to right, we are starting high and we're going towards the vertex. We're going down. So this graph is decreasing to the left of the vertex, which is when x is less than 0. That is the interval that it's decreasing on. And then once we get back to the vertex, if we trace it to the right, we're now going up. That means we're increasing when x is greater than 0 to the right of the vertex. Now, what about this negative 4x squared? What if we have a negative 4 in front? Well, now that vertex is going to stay at 0, 0, but the parabola is going to open down, right? If your a is negative 4, now you're going to open down and still be narrower. So we're going to take this blue graph and reflect it down. So the point 1, 4 will now become 1, negative 4 because we're going down. So 0, 0 still there, but now it's 1, 1, 2, 3, down 4, negative 1, down 4, and now we're opening this way, down. Try to avoid what I just did. Try to keep it going wide, right? Like, let me erase. Right, when you draw your parabolas, try not to go straight down with it if you can. Try to have it always going a little bit out wide. I know it's hard, especially with me drawing like a little bit out wide. Yeah, okay, that's better. So now, if I'm looking for increasing or decreasing, now I'm starting down and I'm going up towards the vertex. So now I am increasing on this left-hand side when x is less than 0. And now once I get to my vertex and I keep going to the right, now I'm going back down. Now I'm decreasing on the right-hand side when x is greater than 0. Let me erase these red marks I made at the beginning. So again, just be careful there about which way it's opening and the increasing and decreasing. Now real quick, I just want to show you back on Desmos, Ohio. That table of values idea, right? So I'm going to come here. So I'm going to delete these two. So remember, once you have that, if you click on the gear and you go table of values, it will give you that table of values. So if you change this to a 3, right, it gives you the new value. So ours was a 4. So there's that 0.14 as promised, right? So again, don't forget that gear and then the table button. Okay, last problem coming on these notes. Okay, so application. So it says the owner of a new dance studio is installing wooden floors in all of the dance rooms. How much should the owner expect to spend on flooring for a square room with 15 feet side lengths? So why is this a quadratic application? Well, it's this idea of being a square, right? When you are a square, right, this is all about area. When we're trying to cover the floor, this is an area problem. The area of a square, just like the area of a rectangle, is base times height, right? Or length times width. But in a square, the sides are the same. You can call them S and S or X and X, whatever you want to do. So if we multiply X times X, we get area equals X squared. This is why area of squares is a quadratic application. Now, in this problem, they're telling us that every square foot costs $8.75. This is going to be our A value. That is what we're multiplying the area by. So this function, this area function, and again, if you want to be very, very technical, it'd be capital A of X equals, so this is A of X equals, it'd be 8.75 X squared. That is our area function. So now we have 15-foot sides. Well, that is our X value. That's our input. So just plug it in. So A of 15 equals 8.75 parentheses 15 squared. Ignore the A of 15. We're just going to take 8.75 and times it by 15 squared. So 15 squared, 225. 225 times 8.75 is $1,968.75. So again, if you do it in pieces of parts, it'd be 8.75 times 225, and that is $1,968.75. And that is how we use a quadratic function to model a cost function for area, and this is of flooring this space. Okay? All right, thanks for watching. Good luck on your practice.